Steady now, keep the tension. It's engaging, full power!
Stand in a modern city and look around. Steel towers scrape the sky. Bridges stretch across water with casual confidence. Electricity hums invisibly through walls. It feels like the natural result of progress. But here is the uncomfortable truth. Many of the engineering problems we congratulate ourselves for solving were already mastered thousands of years ago by civilizations we often describe as primitive. Without computers, without modern mathematics, without industrial machinery, they solved problems that still challenge engineers today. And then, somehow, much of that knowledge was forgotten. This is not a story about mystery or lost aliens. It is a story about human intelligence, patience, and an understanding of nature so precise that it borders on genius. Ancient engineers did not fight their environment. They listened to it. They shaped stone, water, wind, and gravity into solutions that endured earthquakes, floods, and centuries of neglect. Some of their creations still function today. Others were only recently rediscovered, buried beneath soil, politics, or historical arrogance. To understand how extraordinary these achievements were, we must first understand the problems ancient civilizations faced. Cities grew rapidly. Populations concentrated around rivers and trade routes. Water had to be moved uphill. Waste had to be removed. Buildings had to survive seismic zones. Food had to be stored, transported, and protected. Time had to be measured accurately for agriculture and religion. These were not abstract challenges. Failure meant famine, disease, or collapse. One of the most astonishing examples of ancient problem-solving lies beneath the Mediterranean Sea. In the early 20th century, sponge divers recovered what appeared to be corroded bronze fragments from a shipwreck near Greece. For decades, it was dismissed as debris. Only later did scientists realize they were looking at the Antikythera mechanism, a complex system of interlocking gears dating back over 2,000 years. This device was capable of predicting eclipses, tracking planetary movements, and modeling astronomical cycles with precision unmatched until the medieval period. It solved a problem modern engineers associate with advanced computation: how to model cyclical, non-linear celestial motion. The Greeks achieved this not with electronics, but with mechanical logic encoded in bronze. When the knowledge to build such devices vanished, humanity lost centuries of technological momentum. Water management posed another seemingly impossible challenge. Cities cannot survive without reliable water, yet many ancient settlements were built far from rivers or atop hills for defense. The solution was not brute force, but elegance. The Romans perfected this art through aqueducts that remain among the greatest feats of civil engineering in history. Structures like the aqueducts of Rome carried millions of liters of water daily over vast distances using gravity alone, maintaining gradients so subtle they are difficult to replicate even with modern surveying tools. Roman engineers solved multiple problems simultaneously. They delivered clean water, reduced disease, supported sanitation, and enabled urban growth. Their secret was not advanced materials, but precise geometry, standardized construction, and an understanding of hydraulic behavior. When the Roman Empire fell, much of this knowledge was lost in Western Europe. Cities shrank. Sanitation collapsed. Disease spread. The absence of engineering proved just as powerful as its presence. High in the Andes Mountains, another civilization confronted an entirely different set of challenges. The Inca Empire had no iron tools, no wheeled vehicles, and no written language. Yet they built cities that still defy explanation. Machu Picchu sits atop a mountain ridge in an earthquake-prone zone, exposed to heavy rainfall and landslides. And yet, it stands. The Inca solved problems of seismic stability, drainage, and structural integrity through stonework so precise that mortar was unnecessary. Their buildings flexed during earthquakes rather than collapsing. Terraces prevented erosion and managed water runoff. Underground drainage systems carried rainwater away before it could undermine foundations. These solutions were not accidental. They were the result of generations of experimentation and environmental observation. In Southeast Asia, engineers faced a different enemy: monsoon flooding and unpredictable rainfall. The Khmer Empire responded by constructing one of the largest hydraulic systems in the ancient world. At Angkor, a vast network of reservoirs, canals, and spillways regulated water across seasons, supporting agriculture for a population of nearly 1 million. This system transformed excess water into stability, solving the problem of seasonal extremes through scale and planning. Modern satellite imagery has revealed just how sophisticated this system was. It was not merely irrigation. It was climate adaptation. When maintenance failed and political stability collapsed, the system broke down. Floods and droughts followed. The city declined. Engineering, once again, proved inseparable from governance. Even in arid environments where water seemed impossible to secure, ancient engineers found solutions. In Persia, Qanat systems transported groundwater across kilometers of desert without pumps or evaporation loss. These underground channels maintained stable temperatures and reliable flow, sustaining agriculture and cities for centuries. Some Qanats are still in use today, quietly outperforming modern wells in sustainability. One of the most overlooked engineering challenges of antiquity was waste management. Disease spreads rapidly in dense populations, and ancient cities learned this through tragedy. The Indus Valley civilization addressed this problem with urban planning that would not be rivaled for millennia. Cities like Mohenjo-Daro featured standardized brick construction, private toilets, covered drains, and regulated waste disposal. This was not luxury. It was survival engineering. Road construction posed another immense challenge, especially across vast empires. Roads had to endure weather, heavy loads, and constant use. Roman roads were layered with stone, gravel, and mortar, designed for drainage and durability. Many still form the foundation of modern highways. The Romans understood that infrastructure was power. Armies moved faster. Trade flowed more efficiently. Control extended farther. Perhaps the most emotionally striking engineering achievements are those built not for utility, but for time itself. Ancient societies needed to measure seasons accurately to survive. Agriculture depended on calendars. Religion demanded precision. Structures like Stonehenge aligned with solstices and equinoxes, encoding astronomical knowledge in stone. These were not primitive monuments. They were scientific instruments on a monumental scale. In ancient Egypt, the construction of pyramids solved a logistical problem that remained staggering. How do you organize tens of thousands of workers, transport massive stone blocks, maintain food supply, and align structures with celestial precision? The answer was systemic engineering. Ramp systems, workforce rotation, centralized planning, and astronomical observation combined into a project that functioned as a national enterprise. The pyramids were not built by slaves. They were built by a society capable of unprecedented coordination. The emotional weight of these achievements lies not just in what was built, but in what was forgotten. When political systems collapsed, libraries burned, and traditions were broken, engineering knowledge vanished. Not because it was flawed, but because it was not recorded in ways that survived upheaval. Oral traditions faded. Skilled artisans died. Societies rebuilt from fragments. Modern engineers rediscover ancient solutions again and again. Passive cooling techniques inspired by Middle Eastern architecture reduce energy use. Earthquake-resistant designs echo Incan stonework. Water harvesting mirrors ancient systems. Sustainable urban planning revisits ideas abandoned during industrialization. What ancient engineers understood instinctively was balance. They worked with gravity, not against it. They respected climate rather than attempting to dominate it. They designed for longevity, not short-term gain. Their solutions were not always faster, but they were resilient. The greatest challenge ancient engineers solved was not technical. It was philosophical. They built for generations they would never meet. They accepted limits. They planned for failure. And in doing so, they created systems that endured longer than many modern projects. These forgotten marvels remind us of something deeply human. Progress is not a straight line. Knowledge can be lost as easily as it is gained. And sometimes, the future lies not ahead of us, but beneath our feet, waiting to be remembered. Ancient engineering was not magic. It was intelligence applied patiently, humbly, and collectively. And the more we uncover it, the clearer one truth becomes. We were never as primitive as we like to believe.